Hi friend, this is Prashant. Today we'll start with some common mistakes done by student when they draw diagram. We'll start with block and tackle system. Now check. In block and tackle system, this is the rigid support. Right? I want diagram for VR is equal to say 4. VR is equal to 4. We'll draw only one diagram. This is the block, this is the upper block, right? This is the frame to which hook is attached, right? This is one pulley, bigger in size, right? This is one. This is second pulley, little smaller in size. Here is a hook attached. This is the lower block, right? This is the hook. This is the smaller pulley, smaller in size. And this is bigger in size. When you draw this diagram, you have to use scale, pencil, and rounder. This is your load, downward, right? Now you start with the strings. String will start like this. It will start from here. It will go like this. It will go up. It will come down. Here it will go like this. Right? It should be a straight. You use a scale for this. Right here is the tension T. Tension T, tension T. Here is your effort. Tension T. All will be T. Right? Now this is what is expected. Now when a student draw this diagram, they will do something like this. This is the rigid support. They will make one block without any hook. They will show this is one pulley, second pulley, third pulley and fourth pulley. And they will attach something like string, SSC, whatever they will show. Now this is not the correct method to draw this diagram. Correct method is this, and here you have to use scale. When you draw these strings, you have to use scale, right? This is upper block, lower block. This load is downward, effort is downward. All other T's will be in upward direction. Many students are doing mistake over here. They will join these two parts. So this is not possible. If they join these two parts, then this block will not move. It will be now attached to now rigid support. Right? This is one problem. Now next we'll go with system of pulley. It will be system of pulley where you have more number of pulleys connected one after another. Right? That is 2 raised to n. This is the last numerical, 11th numerical of part B. Now here you have, this is rigid support. This is rigid support. Now here we have, this is one hook to which one pulley is attached. To this there is a frame. Here is the hook attached. Here is your load acting downward. Next, this is the other end. Here I will use second pulley with the double grooves, right? This is the frame, center, hook attached, and this is the hook attached. Here will be the second part. This is third pulley. Third pulley will be here with the frame and hook attached with the other terminal. And here is the last pulley, which is fixed to a rigid support with the double grooves. Here is the hook attached, yes, hook, and then this will be coming like this. This is your effort, right? Only load and effort will be downward, otherwise all will be. Here I have written this is T1, here also T1, this is your T2, this is T2, T3, and this is T3. here also T3. Just write here rigid support, and you will get 2 marks for this, 2 to 3 marks for this diagram, right? This is the second. Now how the students are drawing, they will write this is rigid support, they will take one hook, they will take one pulley, and to which they are attaching load like this way only. Then they will draw second pulley with the like this. Here they will write third, they attach, and here third pulley like this, and they expect 3 marks for this diagram. Actually expected diagram is this, and what you are drawing is this. You will get 0 marks for this diagram, right? We will go with the next, that is ray diagram, chapter number 4, right? In that part, first that diagram is for lateral displacement. It is a frequently asked question, and many students are doing mistake in that part. It's very straightforward. Check. This is your glass block, right? This is your glass block, right? This is the glass block. So write here glass kept in air. This is rarer, this is denser. Now ray of light is incident obliquely. This is my incident ray, incident obliquely. This is the normal drawn. If this glass slab is not present, the path of incident ray will be like this, right? Now since this is the angle of incidence, it is going from rarer to denser. It will bend towards normal. Here I will draw normal. Now it will go from denser to rarer. It will bend away, right? Just take care that when this emergent ray, say this is PQ, is my incident ray, QR is my refracted ray, and RS is my emergent ray. This RS, that is emergent ray, and the path of incident ray, they are parallel, and the perpendicular distance between these two is the XY, is called lateral displacement. Now what are the angles over here? This is I, this is R, this is R, this is E, right? This angle is called delta, that is the angle of deviation. Now this is the diagram expected. Now how the students are drawing, they will take, this is the glass block, right? They will write this is the incident ray, right? After normal, they will say this is the refracted ray, then they will say this is the emergent ray. This kind of diagram some students are drawing, or some students are showing this line as dotted, right? I don't know whatever they are doing. They will not mention the angle, what is exactly. So that is a mistake, right? Now we'll go with the next part, that is we'll go with prism. When a monochromatic beam of light is incident on a glass prism, monochromatic beam of light, right? Here this is your prism, right? This is your prism, this is the prism, right? X, Y and Z is a prism. In that, say this is the angle of prism, right? This is the monochromatic light. This is called as monochromatic light. This is single color. If this glass prism is not present, the path of incident ray will be like this. Now since it is going from rarer to denser, it will bend towards normal, and after refraction it will bend toward base, right? Now here what you have to do, draw two normals. This is the first normal drawn, this is the second normal drawn, right? This is angle of incidence I1 is equal to I, R1, this is R2, and this is I2 is equal to E. Take this emergent ray in backward direction, this is called as delta, right? So this is the diagram expected. This angle is 90, this angle is what, 90. Now this diagram is expected But how the students are drawing, they will draw. So you have to write name here. PQ is my incident ray, QR is a refracted ray, RS is the emergent ray. This is the complete 2-mark question. Now what the students are drawing, they will draw this part. They will forget to mention this part. Here they will write incident ray, right? This is the original path. Then they will write this way and they will draw it this way. Normal will be drawn like this. This is the normal drawn, and they expect the marks for this. This is the actual diagram. This is what they draw in boards, right? Okay, these are the mistakes. Now check the next graph. Is a graph that is angle of deviation against angle of incidence. Is an angle of deviation against angle of incidence. Check. Nature of graph is like this. Here is a y-axis, x-axis. This is delta on y-axis, angle of incidence on x-axis, right? Now the nature will be like this way, right? It's like an Icse sign. This is the point tip at which where delta is delta m, where I equal to e, right? This is the expected. When student draw this diagram, they will draw like this. So this has to be a tip, right? Then they will not mention what is this part, what is this part. They will draw this kind of graph, right? So this is not expected. So many students are doing like this. This is a total flat, like this kind of structure will be there. So this is not accepted at any level, right? Now the next part is about TIR. What exactly? Diagram for TIR, right? So in that diagram, just check. Here is a diagram for TIR. This is the boundary separating two media. So this is X1. Lower medium is the denser, which is the glass. Upper medium is the rarer, which is the air. Now source of light is in denser medium, so this is the source of light. This is the normal incidence, light travels straight without any deviation. And this is your normal incidence, light travels straight. Now this is my oblique incidence, right? This is the normal drawn. This is angle of incidence I1. This will go like this, refract, because it is going from rarer to denser to rarer, bend away from normal. This is the second incident ray, for which angle of incidence I2, angle of refraction will be R2. Third, this is my incident ray, right? This is the normal drawn. Now for this angle, your refracted ray will go like this. This is your refracted ray R3. This is angle of refraction. This is your I3, is called as critical angle, right? Now my angle of incidence is more than critical. So this is my incident ray. This is the normal drawn. This is the emergent ray, the reflected ray. This is I4 greater than IC, and this is R4 dash. And what should be there? I4 is equal to R4 dash. This is according to laws of reflection. Now how the students are drawing this diagram, right? They will write this is source. They won't show this normal incident or that part. This is the first incident ray. They will bend this light like this. So the second incident ray, they won't draw normal. They will say this is refracted. So the third, for which they show this way. So this expected is what they will not put arrow also. So expected diagram is this, and what we will draw is this, because this is not accepted at any level, right? Okay. Now next will be to turn light by 90 degree, 180 degree, all that diagrams that I will go quickly, right? Expected. No, here I will draw that diagram. Say to turn light by 90 degree. This is my isosceles prism, right? This is my isosceles prism. This is 45 degree, 90, 45 degree, right? This is my incident ray, normal incidence. It's traveled straight. This is 45. Obviously, this angle will be 45 degree. This is the normal drawn, right? This is 45 degree. It will reflect like this because this is more than critical. Because your eye is 45 degree, critical angle is 42 degree, so your eye is greater than Icse, and it is going from denser to rarer. So this will reflect like this. This is one ray. Second ray will be, this is the incident ray, right? This is 90, this is 45. Obviously this is also 45. This is the normal drawn. This is again 45 degree. It will get reflected with the 45 degree. This is 90 degree. This is also 45 degree. This is what is expected from the student. But how they draw, they will show, this is the diagram. They won't mark this part. They won't mark these two angles. They will say this is the incident ray, right? They will not draw normal. They will reflect like this. They will plot this way, and they will show this is the reflection. This is an incomplete diagram. You will not get 0 mark also for this, right? This is a very bad diagram. Now, when to turn light by 180 degree, that is again important diagram. Okay, that is one important diagram. Say this is your isosceles prism, but placed in reverse order. This is your isosceles prism. This is 90 degree. This is 45 degree. This is 45 degree. Right? This is my incident ray. Incident normally this is 90. This is 45 degree. This is the normal drawn. This is again 45 degree. It will reflect like this. This is 45 degree. 45 degree. This is 45 degree. This is normal 45 degree. It will get reflected like this. This is 90 degree. Right? This is one ray. Second ray will go like this. This is my second ray. This is 90. This is 45 degree. This is the normal drawn. 45 degree. It will go like this. Right? Here also 45 degree. 45 degree. 45 degree. 45 degree. And it will reflect like this. Right? The width of this incident ray and emergent ray will be, should actually be same. AB is my object, then this is A dash, B dash is your image. Width should be same, right? Now the students are drawing, they will show first this is the triangle, isosceles triangle. But this is not 90 degree. Then whatever diagram you are drawing, you will not get mark for this. This they will draw this way, you will get 0 mark for this. Right? This is the biggest mistake done by student. Okay. Next we'll go with complete the following diagram, that kind of questions. Complete the following diagram, that kind of question. Now check here, they have, or say this is one frequently asked question. This is last year's board question, 2019. This is 90 degree. This angle is given, right? This is 42 degree. This is the normal drawn, right? This has to be 48 degree. This is more than critical, so it will TIR 48 degree, 42 degree. This is 48 degree. I will draw normal over here. This is 42 degree. More than critical, it will go like this. So they are 90 degree, right? This is one diagram. Now students are doing mistake over here. They will what? They will show this is this way, either this way, or they will reflect this. These are the mistakes, right? It should go like this. Now next, suppose complete the following diagram. So 30, 90, 60. So this is a prism, say 90 degree. This is 60 degree. This is 30 degree, right? Suppose ray of light is incident like this. This is 90. This is 30 degree. See the normal drawn. 60 degree. More than critical. It will reflect like this. This is also 60 degree. This is 30 degree. Right? I will draw normal over here. This is 90. This is 30. So this is 60 degree. If this is 60, so this comes out to be 120 degree. This is 120, this is 30, so this has to be 30 degree less than critical, therefore it will reflect like this. But many students are doing mistake in this part. They won't come to this part conclusion that this they will sometimes they will show like this, structure will be something like this, right? They will show like this, they will bend this like this, they will plot diagram normal over here. That kind of mistakes are done by student, right? Now we'll go with the one last diagram. Well, many students are doing mistake. I'll show the diagram. Check. Again it is 30, 90, 60 prism. This is the prism. This is 90 degree, 60 degree. This is 30 degree. And this is the incident ray, right? This is 90, this is 60, so this is 30 degree. I will draw normal. This is 60 degree, more than critical, so it will reflect like this. This is 60 degree. This has to be 30 degree. Now this is 30, this is 90, so this is 60 degree. I will draw normal, so this is 30 degree less than critical. It will reflect like this, right? So many students are doing mistake from here only, and they will jumble up with something else, right? Now there are two diagrams where there is no TIR in 30, 60, 30, 90, 60 prism. Just check, no TIR. So this is one 30, 90, 60 prism, right? This is 90, 60 degree. This is 30 degree. The next will be same. This is 60 degree. So 90, 30 degree. Now here, this is my first incident ray. This is 90, this is 60, this is 60 degree. I will draw normal over here. This will be 30 degree, less than critical. It will reflect like this. Now here, this is my incident ray. It will incident like this. This is normal incidence. This is 60 degree. This is the normal. This is 30 degree, less than critical. It will reflect. Now many students are showing TIR over here. In this diagram they will show light will reflect like this. They will show light will bend like this. So this kind of mistakes are done by students, right? That's it for this video. Thank you, students. Hi friend, this is Prashant. Today we'll start with some common mistakes done by student when they draw diagram. We'll start with block and tackle system. And check.